Hey, what's up? I'm John. Welcome to the HTH 2021 CTF Solve series. In this video, we're going to be taking a look at the first reverse engineering challenge called Gatecode. Let's go ahead and get started. All right, so Gatecode, again, is the first reverse engineering challenge. We had 16 solves, so not too bad. We'll go ahead and download Gatecode. I already have it here. If we run file on this or try to figure out what type of binary this is or what type of file it is, that comes back as a x86 64-bit ELF executable. So that means it's something that was designed or compiled to run on Linux. We will go ahead and copy the connection information and see what happens when we connect to the service. So the Gatecode binary is exactly what we're interacting with. It's what we're connecting to here over Netcat. So I type in some information, it'll tell me incorrect pin. Do this again, incorrect pin. So we have to try to find a way to locate this information and maybe the incorrect pin information and see where in that binary the correct information is. And we want to figure out how we get down that code path. So let's go ahead and take a look. There's a few different tools that we can use for this because it's super easy to set up and just use. I went ahead and created an account on cloud.binary.ninja, and we will use Binary Ninja Cloud Platform for this. So I will go here, put this up. We don't need the advanced options. Binary Ninja makes commercial software similar to a lot of other reverse engineering tool suites out there. The really nice thing about Binary Ninja is a really awesome API that you can develop in both C++ and Python and do some really, really cool stuff with it. So we're going to be using the more limited version of the Binary Ninja Cloud, but it's going to work for us just fine. All right, so once everything loads up, I'm going to go to the main function. Here we're in disassembly. So this is the x86 64 assembly code. We're not going to reverse engineer this way because Binary Ninja has a really nice IL suite. So if I click on this, it's going to bring us to LLIL. IL stands for intermediate language. LL means low level. It also has a medium level and a high level. There are different amounts of analysis and types of analysis that goes in lifting it from the disassembly to low level, which gets some basic information, up to medium level, which starts to do some like stack resolution, type resolution. And when we go up to high level, it removes a lot of the intermediate variables and kind of cleans things up for us, makes it look a lot more like the code that we would write ourselves. So a nice pseudo C, right? So this layout is the CFG or control flow graph view. This is a nice graph where we have basic blocks separated by predicates. Predicates are a decision. That's it. It's, hey, should I go this way or that? What should I do? It's a logic case where we determine which way that will branch in execution. So there's a lot of stuff down here. I see the Nexus Data Warehouse East, which we already saw when we ran this. I see an incorrect pin over here. I scroll down, I see another incorrect pin. I see some path down to welcome to the Nexus Data Warehouse, and it reads the flag. So I know I want to get from this basic block here down all the way to this location. So these functions are going to be the ones that I want to analyze and understand. Let's take a look close here. I have malloc, which is going to be taking in 32 as its argument. So it's going to go to the heap, the memory manager, and say, hey, give me 32 bytes on the heap. It'll give it a location, excuse me. All right, so it'll give it pointer to 32 bytes on the heap, if not a little bit larger. Then it's going to go ahead and memset that 32 bytes to 0. And then it's going to check to see if we got the actual pointer. If for some reason the system wasn't able to give us that heap memory, then we're just going to go ahead and bail. So after that, we print something to standard out, and then we ask the user for input. We're going to receive 7 bytes of data from the user, and then we're going to check our string length. If our string length is not exactly 6, we are going to go down to this location of invalid pin. So let's say the string length was 5. Is 5 not equal to 6? And the answer is yes, that's not. So we're going to take the correct or the true branch, right? The yes branch, which is green. If this value is exactly 6, is 6 not equal to 6? That's false. 6 is equal to 6. So we fail this condition and we go down the false branch or the red branch to this, okay? So what we're going to be doing is we're going to be calling this function with a pointer to our input. So our input is going to be the pin that we type in. Let's say we just give it 6 ones, okay? So we'll go into this guy. And in this view, the pointer to the 6 ones that we gave it is going to go into var_c, get the address of var_c, and it's going to convert A to I or ASCII to integer. So it's going to be taking a look at that first character and saying, all right, the ASCII form of this, convert it to an integer and tell me what that actually is. So if we resolve this and it was a 6, 6 is not equal to 6 is false, right? So we go down the false branch. Because 6 is equal to 6, right? So if I asked you, is 6 not equal to 6? You'd be like, what? No. So we would go down the false branch and we would set this as 1. If this is a 5, is 5 not equal to 6? Yes, that's true. So we go down the true branch and we set it to 0. So if this is any value other than 6, we are going to go down that path, right? So I can add some notes here and just say any value other than 6. If 6 ret val is 1, okay? We'll do that, and then I'll just call this ret val. So I'm just typing in, how did this happen before? There we go, okay. Ret val. You just press N on it. For comment, you do semicolon on the actual thing. So over here it doesn't. Here? It does work. I'm crazy. Okay, so we're gonna go back and we're gonna see what happens. If this returns 0, then it's gonna say, is 0 equal to 0? Yes, that is true. That is a true statement. So we're gonna go down this path all the way down here to the screen, and it's gonna be incorrect pin. So we need the return value of this thing to be 1. If you go back in here, the only way for it to be 1 is if the input was 6, okay? Cool. So what I'll do is I'm going to rename this, just clicking on the function name, right click and do rename symbol. And I will call this check1. Check1 because we're checking the first character. Over here, what we're going to be doing is it gives us a representation that it's actually just indexing into like an array. So we have our very first character up here, which is the start of this location, this pointer. The second character, or the first spot, as computer scientists, we love to count from zeros. So the 0 spot will be the first spot, or the index 1 will actually be the second, index 2 will actually be the third, right? So on and so forth. So this is going to be checking the second character. So I'm going to name this check2. This is going to be checking the third character. So I'll name this check3. You don't need to do this, but naming things as you go and documenting is always a good thing. I named that wrong. 44, and then we have a check 5. Okay, and then we have a check 6. All right. So we want to get through all of these things. I click on this one. The first one is 6. Okay. So this one, I will here. Hopefully I can get a comment on this. Comment. Do 6. It already adds those nice C style comments for you. Let me go back and remove that. Okay, 6. Okay. This one needs to be a 8. Okay. So very weird that if I press the hotkey for it, it's not giving me something. It's not allowing me to enter something. So what was that? It was an 8. Okay, so right click, comment 8. Cool. So the first two characters, 6, 8 are the first two digits. I go in here, we want 1, so this has to be a 2. And we got to make sure that during analysis of the first one, we were very sure we documented everything here in terms of what this logic looks like. But it could very easily change in any of these. It can change to equals equals, which would flip the order of these things. So we need to be very careful in making assumptions about what the rest of these are. But I happen to know what they are, so I'm going to go ahead and just make those assumptions. So here, we're going to do whatever this one was. 2. Kind of like walking and chewing bubblegum, trying to do this and talk at the same time. Weird. I don't know why sometimes I can get it and sometimes I can't. All right, comments. 2. All right, going to here. This is a 4. One was a 4. Comment 4. This is going to be a 9. Comment 9. This is going to be a 1. Our final one. Comment 1. All right. So we have 682491. 682491. Let's give that a shot and see what happens. All right. So 682491. All right, there we go. So that ended up bringing us down the right code path. Go ahead and copy this. Go back over to here. Put that in, and it was correct. Cool. So not too bad. We really just need to work our way down the logic of this and make sure that we take our time documenting things and kind of working as we go, right? So this wasn't too bad. I think we're going to go ahead and probably use Binary Ninja Cloud in another challenge just so we can get better familiarity with it. But other than that, I think that's pretty much it. If you have any questions, feel free to write them in the comments. Otherwise, we'll see you in the next video.